The next one is distributions. Okay, so almost every statistical, not every test, but a lot of the tests that you'll do in statistics make an assumption of a normal distribution. Okay, and that's also many times referred to as the bell-shaped curve. So I have an image on my screen of the bell-shaped curve. And a lot of times in your statistical textbooks, this literally is like the first page of chapter 1. You'll see a picture of the bell-shaped curve. And then you'll see a bunch of tables in the appendix that kind of freak you out. Okay, so that's where statistical anxiety can come in. But let's take a look at what distributions and what a normal distribution looks like. It's also important and good to know what an abnormal distribution looks like. It may be a skewed distribution, it may be bimodal, and sometimes you have to look at your sampling techniques to really determine why your distribution is what it is. If you randomize your sample, if you have a normal distribution and you've randomized and you have enough, large enough sample, then you should have a good representative sample. Sometimes your statistical technique may be stratified, or it may be a convenience sample. Let's take a look at how some of these look. So these are some examples of some distributions. So in the upper left, I have an example of a histogram. And this is in the the one to the left is a relatively normal distribution. They're not always as pretty looking as the bell-shaped curve, but they kind of have that look to them. Sometimes you'll have a distribution that we call skewed, and a distribution can be skewed one way or the other. So this distribution is skewed to the left. So if you look, most of the samples in this are to the left side of the graph. Another example, and it may be superimposed over my web links. I'm going to move that down. There we go. Sometimes you'll have what's called a bimodal distribution. So what happens is sometimes you have actually more than one distribution kind of superimposed on one another. Let's use an example here. Let's say we want to look at the height of people in the United States. So if we got a sample of heights of people that live in the United States, we would get probably a bell-shaped curve. But within that bell-shaped curve, we would have to recognize that we would have males and females. And so if we actually drew those out, we may end up with two separate curves that are sometimes superimposed on one another. When you're looking at your data, sometimes that bell-shaped curve looks kind of funny. It may have, more than one hump to it. And that would mean that that there's actually, different types of distributions within that bell-shaped curve. The last thing about distributions is, the bell-shaped curve on the bottom of the slide here. So again, when we look at a perfectly normal distribution, and we think of measures of central tendency, like the mean, the median, and the mode. So the line in the middle, that's the mean. It's also the median and the mode of the distribution. The two lines on either side represent the standard deviation, and sometimes you can even go out to multiple, 2 or even 3 standard deviations. And that's what we're going to talk about next, is the variability or the variance within a sample. Would you catch your breath here? Let me catch my breath. All right. Okay, so we may talk about variance or variation. And what we're talking about here is the scatter and the spread of data within your sample. And let me use an example. When I drive to work, I have a commute time. And actually, I have a pretty ugly commute time. It's about an hour and 15 minutes is my average commute time. But if I don't have any traffic, if I drive during off times, I can get to work in about an hour. But if I hit work during rush hour, sometimes it can be an hour and a half or more. So even though my average commute time is an hour and 15 minutes, if like this morning, for example, I had a meeting early in the morning, so I had to make doubly sure that I was going to be able to make my meeting on time. So what was I doing? I was looking at the variation in my commute time. I was actually using statistics. I was thinking, what would be the worst case scenario? Okay, if there's an accident and I hit all of the red lights, it could take me as much as an hour and 45 minutes. Okay, so what I'm doing is I'm applying a statistical concept to an everyday type of thing like a commute time. And you can use that in, virtually any type of thing that you're looking for. But when we talk about variance or variation, we're talking about a couple of different things. We're talking about a standard deviation. A standard deviation is how much the data varies from one sample to the next. So if you go back to my previous slide and you look at the graph on the bottom with the perfect bell-shaped curve, take a look at that for a moment. If there was no variability, it wouldn't even look like a bell-shaped curve. It would just simply be a vertical line because every sample would be one on top of the other. But we know that that's not the case. If we look at the heights of everybody or the age, let's say everybody that's the age of everybody here tonight. I'm not going to ask you to put your age in the chat, but you know what I mean. There would be an average age. Let's say, for example, the average age of everybody here is 40. My age is 51. Okay, so I'm a little bit higher than the average. So there's some variability. If we took that variability of everybody that's in this webinar, we could calculate our standard deviation, how much that varies from the mean. Another thing we can do is we can look at the standard error. Okay, so we have, millions of people that are in the country. We have thousands and tens of thousands of students that attend Walden University. Okay, and we have a sample here tonight of people who are Walden students. And so, but how good is that sample? So if we did the average and we looked at the average age of this group and the average variability, and then we do another webinar, I think we're doing another webinar Saturday morning, and we did the same thing, we wouldn't get exactly the same results. Hopefully they would be pretty close. But what the standard error does is it basically, it's looking at the sample size, and it's really trying to help us figure out how good is that sample. And the larger the sample, the closer the standard error is going to be to our sample mean. Because we don't always have the full population. We wouldn't measure the age of every student in Walden. Somebody probably could, but we wouldn't have access to that. But if we did a sample, we could probably come pretty close. Another one would be the range. A range is just simply the lowest and the highest value. And the variance, and let me give you an example of variance. There's a couple of different ways depending on the type of data you're using to calculate variance. This is looking at a regression line, a correlation of two variables. And we could calculate, we're going to do this in one of the subsequent webinars, we could calculate the correlation coefficient. So we might, and that's called an R value. So let's say, for example, we have an R value of 0.8. That's a pretty good correlation. What we're looking for also is the variance. The variance is the R squared. So 0.8 times 0.8 would be 0.64. What that's looking for is how much of the variation in one variable can be explained by the other variable. Okay, so let me give you another example. So take a look at this line here, and now we have another sample. We have the exact same regression line, okay, but the samples are a little bit they're spread farther apart. There's the correlation in this group would be much lower, and the variance would also be much lower. It doesn't do as good of a job of explaining the variability in these data. So that's how we look at variance and variation in our sample.